Hello guys, welcome back to another problem solution video. Today we'll be at another question here, and as always, let's first start off by reading the question. So this is from the COMC 2003 contest, and this is the fourth and final question of part B. So the polynomial equation x to the power of 3 minus 6x squared plus 5x minus 1 equals 0 has three real roots a, b, and c. So determine the value of a to the power of 5 plus b to the power of 5 plus c to the power of 5. So here, we're going to be using Vita's formula. So if you don't know what Vita's formula is, I'll tell you right now. So I'll just write Vita's formula, or formulas, to be more specific, because there's multiple. So, the first one is going to be that a plus b plus c is going to be equal to the negative value of the second coefficient divided by the first coefficient, which is going to be equal to 6. So a plus b plus c is going to be equal to 6, where a, b, and c are the roots. ab plus b plus ac, so plus bc is going to be equal to the value of the third coefficient divided by the first coefficient. So 5 over 1 in this case is going to be equal to 5. And all three of these roots together, so a, b, c, is just going to be equal to the negative value of the last coefficient, so the fourth coefficient divided by the first coefficient. And this is going to be equal to 1. So, we're now going to be able to see here that a squared plus b squared plus c squared is going to be equal to, in brackets, a plus b plus c squared minus 2 times ab plus ac plus bc. And this is going to be equal to 6 squared minus 2 times 5, which is going to be equal to 26. So I just plugged in the values from here. So now we're going to do the same thing for a to the power of 3 plus b to the power of 3 plus c to the power of 3. So a to the power of 3 plus b to the power of 3 plus c to the power of 3. This is going to be equal to 6a squared minus 5a plus 1, I'll explain why, plus 6b squared minus 5b plus 1 plus 6c squared minus 5c plus 1. Now, where did I get these numbers? So 6a squared minus 5a plus 1, 6b squared minus 5b plus 1, and etc. Where did I get this? Well, we can see here, going back up here, if we just plug in a, b, and c, this should be equal to 0. So plugging this in, I'll go up here, we can get a to the power of 3, minus 6a squared plus 5a minus 1 is going to be equal to 0. b to the power of 3 minus 6b squared plus 5b minus 1 is also going to be equal to 0, and c to the power of 3 minus 6c squared plus 5c minus 1 should also be equal to 0. And this is because a, b, and c are the real roots of this equation here, and if we just plug them in here, they should be equal to 0. So plugging them in here, we can see here that now if we, this 3 looks really wrong, I'll fix it. If we move this part of the equation, so this part, and this part, if we move that over to the right side of the equal sign, we can receive what a to the power of 3 is. And going back down here, we know that we need to find a to the power of 3 plus b to the power of 3 plus c to the power of 3. So we just plug in what's on the right side of here. So 6a negative 6a squared plus 5a minus 1. We move it here, so we change the signs, then the negative positive signs, to receive 6a squared minus 5a squared plus 1. And we do that for all three of a, b, and c. So now we're going to simplify this into, so we're going to expand it and get rid of all of these brackets. And then we're going to add new ones to receive this. And this is going to be equal to, so since we know what a squared plus b squared plus c squared is, from what I said before, as a result, it's going to be equal to 26. We're just going to plug this into here, and then we receive, so 6 times 26 minus 5 times 6 plus 3, and this is going to be equal to 129. So now let's solve for a to the power of 4 plus a to the power, b to the power 4 plus c to the power 4. Now this is going to be a times a to the power 3 plus b times b to the power 3 plus c times c to the power 3. And actually, I'm going to use the brackets here so it's easier to see. Right? And then after, this is going to be equal to, well, a, b, c in front, and then what we have from b to the power 3. So I can turn this into a plus b plus, sorry, actually I can't do this. I did something wrong. Not to say that, you can then expand it, so a times 6a squared minus 5a plus 1 plus 6 times, sorry, no, not 6, b times 6b squared minus 5b plus 1, and then I have to go down the line, plus c times 6c squared minus 5c plus 1. Sorry there, I messed up. So you will then expand what a to the power 3 is, b to the power 3 is, c to the power 3 is. As I said before, since from this equation, we can just move this across to find out what a, b, and c to the power 3 is. Right, so we just did that and we plugged it into here, like so. And now we're going to expand this, okay? So I'm going to go back down here. This is going to be equal to, so I just had to overlap because I ran out of space. This is going to be equal to 6 times a to the power 3 plus b to the power 3 plus c to the power 3, which is minus 5 times a squared plus b squared plus c squared plus a plus b plus c. And this is going to be equal to 6 times 129 minus 5 times 26 plus 6. And this is going to be equal to 650. Right? And now we're going to add the final part of what a to the power 5 is, plus b to the power 5 is, plus c to the power 5 is. So essentially, this entire question is about plugging in numbers from Vita's formula and going down the line. So a squared plus b squared plus c squared to a to the power 3 plus b to the power 3 plus c to the power 3 to a to the power 4 plus b to the power 4 plus c to the power 4, all the way down to what the question actually asks for, a to the power 5 plus b to the power 5 plus c to the power 5. So here, similarly from what we just did up top, a squared, a to the power 3 plus b squared, b to the power 3 plus c squared times b to the c to the power 3. And now this is going to be equal to a squared times 6a squared minus 5a plus 1 plus b squared times 6b squared minus 5b plus 1 plus c squared times 6c minus 5c plus 1. Then we're going to expand this and group them all back together while multiplying the a squared in. So 6 times a to the power 4 plus b to the power 4 plus c to the power 4 minus 5 times a to the power 3 plus b to the power 3 plus c to the power 3 plus a squared plus b squared plus c squared. And this is going to be equal to 6 times 650 minus 5 times 129 plus 26, which is going to be equal to 3,281. This means that the answer to this very long problem is going to be equal to 3,281. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.